All right, this is how to experiment well and how to do a completely randomized design. So we're going to explain the purpose of comparison, random assignment, control, and replication, which is all the 4 principles of experimental design. We'll talk about that. Okay, you're going to have to describe how to do a completely randomized design, and then we're also going to talk about like what happens when you have the placebo effect, and also the purpose of blinding and what blinding is. All right, we're going to do a little experiment today. So we're going to check our pulse to start. All right, so everybody put your finger here or here, wherever you can feel your heartbeat. Okay, we're going to do it for 15 seconds, and then you're going to times by 4, so you get your pulse, okay? So multiply that number by 4, okay? Write it down so you have it. All right, so do you guys think caffeine has an effect on your heart rate? All right, so what if I poured all of you guys a nice caffeinated beverage, had every single one of you guys drink it, okay? This will help out some of you in this class. Have every single one of you guys drink it, and then compare your pulse rate again in 10 minutes. What's wrong with that experiment, like the design of the experiment, if you all have a drink of caffeine and we test your pulse in 10 minutes? Yes. What did you say? Yeah, what if everybody just gets excited about the pop and that's actually why the heart rate increased? So what's missing from this experiment? Robbie? Yes, we need something to compare it to, okay? So we need some people to drink caffeine and some people to not drink caffeine, ideally, okay? So you must have comparison in an experiment. So the point of a control group, which you might write down, the point of a control group is for comparison. So a control group is used to provide a baseline for comparing the effects of other treatments. Depending on the purpose of the experiment, a control group may be given an inactive treatment, such as a placebo, an active treatment, or no treatment at all. So there are times where we have like one group do exercise and the other group does nothing, right? Or there are times where you might take some drug to see if it improves symptoms for something, and the other people take a placebo drug called like a dummy pill, where it's like looks like the drug, but it's not anything, right? Okay. So the point of a control group is for comparison. Okay, we have confounding variables a lot of the times, and again, that confounding variable could be you're just excited that you get to drink a pop, right? That could be a confounding variable, which is why we have a control group. So remember the malaria problem where the schools, we like gave them treatments to help with malaria, and then the other schools didn't get the treatments. So what's the point of having that control group, the kids that don't get the treatment? Well, what if there was just less mosquitoes one year because of a drought, and we actually attributed it to the treatment, right? We wouldn't know if we didn't have that control group, that there was just less mosquitoes that year, and we might be like, oh, the treatment's working, but in reality, maybe it's not actually working. So that's why we have to have a control group, because you don't know those outside effects, such as there's a drought, and there just happens to be less mosquitoes that year, so there's less malaria, okay? So the placebo effect. I don't know if you guys know this, but there's a power of positive thinking. So there was an experiment done where these men were balding, okay? And they were like, oh no, I'm losing my hair, I need to get some medicine. So they go take this drug, and they decided to give a placebo drug, right, to some of them so we could compare. And then an actual drug that's supposed to help with hair growth. Both groups grew their hair, all right? Now, the ones that had the actual treatment did better, but even the ones with the dummy pill, that positive thinking, they're thinking I'm getting something that is helping me with hair growth, and their hair grew too. So that's called the placebo effect, which we have to account for, which is why we have a control group, all right? Because sometimes we just positively think and something can happen. We can have a result, all right? So that's called the placebo effect. So ideally, we want to make our experiments double blind. Like you don't know if you're going to get the caffeine or the caffeine free today, all right? So double blind would mean I also don't know which one you guys are getting. However, I do know, all right? So The reason that double blind helps is, let's say you're seeing if some like exercise treatment helps, and there's somebody who's going to interact with the patients, and they're going to come in and like run on the treadmill and like lose some weight or something, I don't know, right? And they're going to be responding to those people. You kind of want those people not to know who's got the good drug that's supposed to help or the good exercise program or something. That way they're not more positive towards the group that they think should succeed, okay? So ideally it's double blind. Although oftentimes it can only be single blind, which is what today's is, where just one of those groups knows. So like today, you guys don't know which one you're getting, but I do know if you're getting caffeinated or non-caffeinated beverage. That's single blind, okay? Okay, in an experiment, random assignment means that treatment experimental units, that's you guys, are assigned to treatments using a chance process, okay? This is the most important thing of a completely randomized design. So one of them is to have a control group, but this one is also, like, this is the whole point of an experiment, is random assignment, okay? You have to have random assignment to have an experiment. And there are 3 methods, and you need to write out your whole explanation of how you're going to do it. So I could write all your names in a hat, and I could draw out half of you. Let's say there's 20 of you. I draw out 10 names. You're going to be specific. And then you must assign them to a treatment. So I'm going to say the first 10 names I draw are going to get treatment A. Maybe it's the caffeine. Maybe it's not the caffeine. Okay? You want to say, though, which one you're assigning which group. The remaining students will get treatment B. Okay? So that's hat method. If I say calculator method, what do I need to do first? Assign everyone a number, right? Everybody needs a number if I do calculator method. Then I'm going to do random integer 1 through 20 on my calculator. What do I have to say and remember to say on the calculator method? What did you say? Yeah, you don't actually have to say things outside of 1 through 20 because the calculator will only do 1 through 20. So you do need to say on calculator method, skip repeats, okay? I don't want the same person drawn. All right, and same thing. The first 10 people chosen are going to take treatment A. The remaining take treatment B. Be specific. Sorry. Table D. What do I have to do first on table D? Assign everybody what? A number. What's the first number? 01 through 20. Then we read how many digits? 2-digit numbers going left to right. And this is where you say skipping repeats and numbers outside of 01 through 20. Okay, and then assign the treatments. First 10 people, numbers will take treatment A, remaining will take treatment B. All right, be specific. Okay, let's do it. So, calculator. You don't have to do this on your calculator too, you guys. I'm the one, I'll just do it. So probability, random, integer, 1 through 19, all right? We're going to pick 10 numbers to come up here and get treatment A. 6, you're a winner. Come on down. 3, 1, 14. Oh, there's a 1 again. Skip it. 9. Was 6 already picked? Yeah. Okay. 19, yeah, take an A. You can drink it. You can go to your seat. All right, 19. Oh, am I on 7 of you guys? 16, 12, 4. Hopefully that was 10 people. All right, the remaining people can come up and grab a cup B. There should be 9 of you guys. Hopefully I did this right. All right, you guys, so we're going to check our pulses again in 10 minutes. So let's see what time it is after you guys have all drank. I'll drink it all. It's like cough syrup or something. So it's 10:16. We're going to check it at 10:26. Close the door. We're going to subtract the after 10 minutes minus the before. We're looking for a positive, an increase, right, in our heart rate. We're going to see if there's an increase, specifically in the caffeinated ones. All right. Now, I would write this part down. The entire purpose of random assignment. What's the point of it? Why do we do it? Okay? The reason I need random assignment is to create 2 groups of students that are roughly equivalent to begin with. Okay, maybe some of you guys already drank some caffeine. Okay, I'm hoping that you guys are spread out between the groups. Okay, I don't know if you guys know, but I think typically men have a little bit lower heart rate than women. So maybe we evenly distributed boys and girls. Okay, that's the goal, is so that when we start, our heart rates are somewhat equal, or we're spreading out kind of other factors. So maybe some of you just have higher heart rates than others. We're hoping to spread those people out between groups, or the effects of the caffeine. We're spreading it out, okay? So roughly equivalent groups. Okay, there's other things we want to control for. So there's 2 definitions of control. One is a control group, and the other is let's control for other factors that could affect the experiment. So some things we would want to control for, we wanted to make sure you're all drinking the same amount of cola, right? If some of you guys just did a little sip, right, that would definitely change our output. So we want to have everyone drink the same amount, okay? Another thing I did is I bought the sugar ones for both, right? So they actually have like sugar-free, caffeine-free, diet, I don't know. They have all like millions of different kinds of Cokes. This one was just caffeine-free, still has the sugar, all right? So that way I don't know. Otherwise, I wouldn't know if it was like the sugar that affected you or the caffeine, okay? So everything was the same except for the caffeine. Okay, so we need to have a control group for comparison. We need to have random assignments with roughly equivalent groups, and we need to have to control for other factors. And the last thing, what if I just had one student drink caffeine and one student drink the non-caffeinated one? Would that be a good experiment? No, because like maybe they just respond naturally differently, right? I wouldn't know if that was the treatments or just variation between the 2 people, right? So this is called the idea of replication. So replication is definitely a word you've probably never heard before. All this means is I have enough people in each group that I can say if there's a difference that is due to the treatment, not just variation in my sample of who came up here. So we're using enough experimental units, or people, experimental units are you guys, but we know that the difference, if I do get an increase in your heart rate because of caffeine, that the difference was due to the caffeine rather than just chance variation where I just had a certain people who raised their heart rate versus one person who didn't or something, okay? Again, that is on your sheet. Okay, so those 4 things are what you need for a completely randomized design. So if a problem asks you to describe a completely randomized design, I would start actually with the random assignment first, and I would explain your method. Now, don't just say I'm going to randomly assign. Say how. All right? You have to do hat method calculator or table D. You have to pick a method, and you have to assign a treatment. Okay, then you're going to say, I'm going to control for some other things, whatever you can think of. And then you're going to make sure you have enough experimental units. Okay? And then at the end, I would talk about comparison. I don't know why I put it first, but at the end, I would say, well, I'm going to compare heart rates to, and the 2 groups I'm comparing are the ones that had caffeinated cola to the ones who had non-caffeinated cola. All right, let's talk about the physician's health study. Let's see if we can find those 4 things, okay? So, does regularly taking aspirin help protect people against heart attacks? The physician's health study was a medical experiment that helped answer this question. In fact, the physician's health study looked at the effects of 2 drugs, aspirin and beta-carotene. Researchers were wondering if beta-carotene would help prevent some forms of cancer. And then the subjects in this experiment were about 22,000 male doctors. There were 2 explanatory variables, also called factors. Okay, that word factors means explanatory variables. And they each had 2 levels. All right, so one explanatory variable was aspirin, and the other was beta-carotene. But they each had 2 levels because they either had aspirin or they had a placebo pill. They had nothing. Okay, or they had beta-carotene or they had a placebo pill. And then they did 4 combinations of this. So, like, of those doctors, they divided them into 4 groups. Like, 5,000 of them got both. 5,000 of them just got one of the things, like Tylenol or whatever it is, aspirin. One group just got the beta carotene, and then one group got like nothing. Okay, they got placebo pills. Okay, on odd numbered days, the subjects either took a tablet that contained aspirin or a dummy pill that looked and tasted like aspirin. On even numbered days, they either took the capsule that had beta carotene or the placebo. There were several response variables. So they looked for heart attack rate, what kind of cancer, if anybody developed, and some other medical outcomes. And at the end of it, after several years, 239 of the placebo group, but only 139 of the aspirin group suffered heart attacks. Okay, so there was definitely a decrease in heart attacks due to the aspirin. Okay, it had a pretty significant difference. This difference is large enough to give good convincing evidence that taking aspirin actually reduces heart attacks. But the beta carotene did not have any effect on preventing cancer. How did they use comparison, you guys? Anybody? Someone besides Robbie? Heath, what do you think? Yep, they had 4 groups that they were comparing, and some of them were placebo pills. So yes, because of the 4 groups and the placebo pills. All right. What's the purpose of random assignment? Why do we randomly assign, you guys? This is kind of the answer every time they ask. What's the purpose of random assignment in this experiment or any experiment? Somebody raise your hand if you remember what I said. Paul? Yep, so in this case, hopefully 4 groups, because we split them into 4 groups of roughly equivalent, like doctors that were male to begin with, okay? So we're splitting them up so that we even out just kind of the healthy people and the unhealthy people, right? Hopefully those are mixed in between the 4 groups, okay? What other things did they control for in this experiment? Hayden, you have a guess on something else they controlled for? Once you see it, you're like, oh, that's what they're looking for. Mia, do you have a thought? What did all these people have in common, you guys? That was kind of interesting. Yeah, they used all male physicians. So the fact that everybody was male is actually something they controlled for because men and women have different rates of heart attacks in general. Actually, men typically have more heart attack rate, like higher heart attack rate. So the fact that they use all males is actually a good thing. There's more likeness to them, okay? Same with doctors. So they have the same job, meaning they have the same level of stress-ish. Obviously, some of that varies in life, but having the same job makes them somewhat similar. So those were controlled for. Another thing they did was like tell them exactly when to take the pills, stuff like that, okay? And the last thing, how did they use replication? Basically, do you know what this word means, okay? Replication means having enough people. What do you guys think? Yeah, when you divide that by 4, they had at least 5,000 in each group. That's a lot of people. So yes, they had enough replication to say that the difference was due to the treatment, not just chance variation. Let me see what time it is, if we should do our heart rates again. I think we're right on time. All right, you guys, before we get started on our worksheet, let's take our pulse rate.